According to. Okay. All right, so now we're gonna do the basic IB math. The beginning of this is a lot of review from what we just did. And it's that way because we used to give these separately, like you would have what I just gave you one semester and then this the next semester. Now we're getting you into it earlier, so when you go to clinical, you can do a lot more stuff. So it's good for you, kind of, because you get to do more stuff, but it means you get a lot more stuff crammed into your head right now. But it'll be okay, the same, everything that we just applied applies to this too. Okay, so a quick review, I'm gonna skim through this. What I need to know, she repeats the same things. Okay, so this session is gonna be all about IV calculations for pump and for gravity. So when you use an IV pump, you're probably familiar with those. You've seen them. We have pumps from both hospitals here. Because you'll go to both hospital, all the hospital, you'll go to, I'm trying to say, you're gonna go to OSF at some point. I think you're all going to Carl this semester. So for right now, Carl uses Baxter pumps. So these look like this. This is an older version of it. And this is the most newer version. Carl? Yeah. Since when does Carl need this? Oh, Broman. Okay, that's why. In Peoria area. Yeah, that's why. So where you're going, they're gonna use Baxter. So these two pumps, they're both Baxter pumps. They work exactly the same. They just, this one looks a little newer. But the functions are all the same. And then OSF uses this Alaris pump. OSF, yeah. Okay. So they'll look like this, and these you can add channels. So if you have somebody in critical care that has several drips going, this might be sticking way out here on both sides with different channels and meds running through it. So this semester, we're gonna focus everything on learning the Baxter pumps. You got some tubing in your skill bag that you bought. That tubing that is in there is for the Alaris pump, so it's not useful to you right now. I'm gonna pass one around. All right, so it's gonna tell you when I advance the slide about drip chambers and all that. Okay, well, I'll get to that. I'm gonna show you this first. So I'm showing you this is an Alaris tubing. This is like what's in your skill bag. This is exactly what's in your skill bag. So there, yes, that slide. It's going to show you the drip chamber. That's this thing. Okay. And a drop factor. So your drop factor on this Baxter tubing, this is what you're going to be using at Carl. Their drop factor is 10 drops per milliliter. That means it takes 10 drops to come out of this little thing up here to make 1 milliliter. Your Alaris tubing that's in your skill bag, its drop factor is right here, and this manufacturer puts it in a little teardrop that says 20 over ml. So this is 20 drops per mil. So it takes more drops to make a mil for this tubing than it does the Baxter tubing. So I'm just illustrating the difference of that. There's another kind of tubing called micro drip tubing, and that might be 60 drops. That means the drops are really tiny. So it takes a lot more drops to make a milliliter. So I'm just going to pass these around. Seeing stuff helps you to make sense out of things. So these are just different kinds of tubing. And I wanted you to see that how the drop factor might look on different manufacturers' tubing packages. Okay. So then I need to backtrack a little bit and go back a few. Oh, there's our pumps. Okay. On IV calculations, on your pumps, for your math test, I'm going to ask you to round to the nearest whole number. But you will notice if you look at the pumps, both kinds, do have a decimal point, so you can, excuse me, you can do a decimal and be very precise. I'll just ask you for whole number for now. But if you were doing some critical care math in a critical care setting and you came out with a decimal, you can put the decimal into your pump. Okay, but when you're doing gravity, that means there's no pump, it's just running by gravity into the patient. You can't split a drop, right? So if I come out with 4.8 drops or 200.6 drops, it's gonna be a whole number, because I can't split a drop. Right. Now forward. You can see the decimal point. There's one on the Baxter right there. And on the Alaris, it's right there. But we will do whole numbers for now. Okay, a little bit about gravity versus IV pumps. I heard that back in the COVID pandemic, we had to prioritize IV pumps because there were so many patients and there was only so many pumps. So I think there, at that time, there were probably some patients that had gravity drips that normally we don't. Usually we put everything on a pump, most generally. If you have to prioritize and not everybody can be on a pump, that's why we still make you calculate gravity. Even though it's not common today, it could happen. There's always some reason that it could happen that you need to know how to do gravity. So we still teach you how to do gravity drips. Also, there are some settings where they don't use pumps. So maybe in long-term care. Generally speaking, if it's a medicated IV infusion, like it has vancomycin or Rocephin or dobutamine, it's going to be on a pump. If it's just fluids for volume replacement, it could just be gravity. Some scenarios when you might see gravity, for one thing in the field, like the ambulance, they don't use pumps. They start IVs and they just let them run by gravity. But they don't have you for very long either. They'll have you for what, maybe a half hour, 45 minutes, and then they turn you over to the ER nurse. So you might see gravity in the field, you might see gravity in the ER sometimes, and also in long-term care. Or if you have to prioritize because you only have so many pumps and have more patients with IV infusions. Okay. In order to solve a gravity infusion problem, this is the one exception. Whenever you're doing gravity, you always start with your drop factor. So anytime I say you're doing a gravity infusion, my eye should be looking for a drop factor. Okay. And then those answers are going to come out in drops per minute. So your drop factor is drops per milliliter, but your final answer is drops per minute. Okay. But if you're doing an IV pump, it's going to be milliliters per hour every time, always milliliters per hour. Okay. So those are the two things that you would want to know. I have that right here. So if you took a picture of the board, you have that. And then same thing, and answers are going to be rounded to the nearest whole number because you can't split a drop. Okay. But we're going to start with pump problems. We'll do gravity last. So if I'm solving for milliliters per hour, I'm going to start with milliliters on top, just like I did before. Yes.
Can you go back to the last one? Okay.
Got it? Okay. The same principles of dimensional analysis apply. So everything that you learned, you can put right to work with this. That's nothing new. Okay. Let's start with an easy problem. This is going to be a short grid too. You're going to feel like this grid isn't long enough. The physician orders 250 milliliters of D5W to infuse over 5 hours. What rate will I set my pump? So since it's pump, it's going to be milliliters per hour. I'm going to start with milliliters on top. So I have 500, no, I lied, 250, 250 milliliters to infuse in 5 hours. So I write that with 250 on top. Oops, I forgot to ask the 4 questions. Have to do it, so make sure that we do it every time. What unit of measure am I solving for? It's a pump, so it's gonna be milliliters per hour. The order says 250 mils over 5 hours. And I have in my hand a 250 milliliter bag. So that's what the pharmacy sent me. Do I have any conversions? No. All right, so I'm gonna start with milliliters on top, which is my 250. So it's gonna be volume over time. So I got my 250 volume, my 5 hour time. My answer needs to be in milliliters per hour. And I already have that. So I don't have to I don't even have to put anything on this side of the grid. That's all that I have. I don't even have a grid. It's just a fraction. 250 over 5 hours, milliliters per hour. There's nothing to cancel out yet. There will be in the next problem. All right, so I can take that right there, go 250 divided by 5. Oops, that was the answer, which comes out to 50 milliliters per hour. Questions on that one? You'll get one of those and you'll think something's not right. It might be that simple. If you already have milliliters over hours, that's all the longer your grid needs to be. Now we're going to take, as you may expect, we're going to take it a step farther. Okay, the physician orders 500 mils of D5W to infuse over 90 minutes. What rate will I set my pump? So I got 500 over 90 minutes. Okay, it said to use a pump, so I'm looking for milliliters per hour. My order says to give 500 over 90 minutes. I have a bag of 500. That's what I have on hand. And there are conversions. Why are there conversions?
Because of minutes.
Because of minutes. Yep, because I need to be in milliliters per hour. So I have to convert minutes to hours now. Good catch. So I'm going to start with my mils on top, which is 500 over 90 minutes. So what am I going to put up here then? 60 minutes equals
1 hour.
1 hour. All right, good. See, you got it. 60 minutes over 1 hour. Is my grid done?
Yes.
It is. Because my minutes cancel out. And I have milliliters per hour left. And that's what I'm solving for. Okay. Just multiply it out. And it comes out to 30,000 on top, over 90 on the bottom. When you divide that, it comes out to 333.3, but I need a whole number. So I'm going to put 333 into my pump. So that would be my final answer, 333 milliliters per hour. You can forget you saw this slide. You can reduce in the problem if you are comfortable doing so. Now we're going to move on to some IV piggyback calculations. Is everybody with me so far? The doctor orders vancomycin. Oh, you'll get one of these that'll confuse you. I'm really glad this question's in here. The doctor orders vancomycin 1.5 grams IV every 24 hours. Is that bed or that? It just gets loud every once in a while. The pharmacy sends up vancomycin 1.5 grams. My dose is right. And it's in a bag of 750 milliliters of that, which is normal saline. I don't care what that solution is. And I don't really care about this. I care about it long enough to make sure that the dose is right. But this 1.5 grams does not go in my grid. Okay, only volume and time. So I'm going to look at that to make sure, because I'm doing my 8 rights of medication administration and making sure my dose is right. But then I'm going to disregard that when I'm calculating my rate. And does everybody understand that that doesn't go in your grid? Okay, you will do it, somebody will do it and be like, I don't know why this isn't coming out, because you got your dose in there. And sometimes you just gotta make that mistake once in practice, we'll do it in practice in here. You'll make that mistake and be like, ah, okay, and I think I have that somewhere, I had it somewhere. The prescribed, yes, for IV rates calculations, the prescribed dose doesn't go in your grid. Okay. All right, so what rate will I set my infusion pump? So it says pump, so I'm gonna be in what units? What am I solving for? What is it? Milliliters per hour. Okay. All right. Only volume and time, the other information is part of the order and needed to perform the three checks of med prep and 5/8 in parentheses, rights of medication administration. Okay, so what unit am I solving for? It's a pump. So in my mind, I know I'm solving for milliliters per hour. My order says Banco 1.5 grams IV Q24. On hand, I have Banco 1.5 grams in a bag of 750 milliliters. And the sticker on the bag, the pharmacist will put a sticker on it and it will tell you what time frame to infuse it over. The doctor doesn't tell you that, the pharmacy tells you that. Okay, the doctor orders the dose, the pharmacy mixes it, and they tell you the infusion, the length of time it should infuse by. So there will be a sticker on it that'll say over 2 hours. There are no conversions yet. So I'm gonna start with my milliliters on top. And that's my 750. I got a 750 ml bag. It's got to go in over 2 hours. Okay. Do I need to make my grid any bigger? Because I'm solving for milliliters per hour, but it looks like that's what I already have, right? Okay. So I just multiply that out and I'm going to set my pump at 375. So that was a good question because it had the dose in there that you don't need. And that had a short grid too. So that was kind of a good one. Okay. And these are on Canvas too. You just didn't see it because it was invisible earlier, but now it's on there. So you can look at this presentation later if you want. All right, good. Okay, let's do one with the conversion. The doctor orders cefazolin 1 gram IV every 8 hours. The pharmacy sends me cefazolin 1 gram, but it's in a little 50 ml bag. So I had a 750 ml bag. That's a pretty big bag. This is a little bitty bag. And it is to be infused. The sticker on it says to put it in 30 minutes. Infuse it over 30 minutes. What rate will I set my pump? So I've checked my order. My order says 1 gram. I've checked my bag. It says it's got 1 gram. I'm good with 1 gram and I can forget about that. That doesn't go in my grid. So I'm going to start with what on top. I'm using a pump. So what's going to go on my top left stack? 50 milliliters over 30 minutes. Is my grid done? No, it's not. And why is that? You gotta convert. I gotta convert the minutes to hours. Yep. So I need minutes up here. So what am I gonna put there? 60 minutes. 60 minutes over 1 hour. Now is my grid complete? Yes, it is. My minutes cancel out. And I'm left with milliliters over hours. Now I can multiply. Comes out to 100. Oop, no, that's not right. 3,000. Oh, that's the final answer. Yeah. Okay. 3,000 over 30, which comes out to 100 an hour. Some of your questions you can do in your head. This might be one that you could do in your head. And here's why. I'm going to go back to the original question. If I have a 50 ml bag, and I wanted to run it in an hour, I would set my pump at what? 50 an hour, right? If I want it to go twice as fast, like in this, it says 30 minutes. I'm gonna run it at 100 an hour. So there are some questions that you can step back and like think, does this make sense? So whenever you get something that seems a little unusual, like if you're doing something, you come out with 40 tablets or 800 tablets, something's not right. Which should tell you, that doesn't sound right. I need to redo that question. Or have somebody else do it alongside me or something. All right, but this is one of those that you could look at and not have to do the calculation. But if I give it to you on a test, you guys show all your work on it. One scenario you cannot do that with is gravity. Gravity drips. You can't ever look at it and think, well, that doesn't make sense. You just can't. You can do it with milliliters per hour, but not drops per minute. Are you ready for gravity? Okay, it's not so bad. With gravity, you just remember you always start with your drop factor. Always, always, always drop factor first. Okay. The problem will look the same. And I can do this. Sometimes I give practice problems and I'll give the exact same order, but say calculate it on a pump and calculate it gravity. You can do it both ways. It will be a far different answer. On this one, the physician orders 1,000 milliliters of D5 normal saline to infuse over 10 hours. And the IV is a gravity drip. And the tubing has a drop factor of 15 drops per milliliter. What rate will you set your tubing? Since this is a gravity problem, we're going to solve for drops per minute. And we start it the same way. We're solving for gravity, which means drops per minute. Pause. On your test, there will always be, on the test I make you, the competency test, there will always be the question and there will be this little blank for you to write your final answer on. And the blank has the units you're solving for. So if you're ever like, oh gosh, is this one drops per minute or milliliters per hour? Just look at the blank. I gave it to you. And then that's what you're going to use to start your grid. The order says 1,000 mils over 10 hours. You have 1,000 mil bag in your hand. And we do have conversions because it says over 10 hours, but my final answer has got to be in drops per minute. Okay. So I'm going to start with my drop factor. I forgot what it was. Okay, 15 drops per 1 mil. So now what do I need up here? What unit? Milliliters. And it's going to be what? 1,000 milliliters over 10 hours. Am I done with my grid? Nope, because I need it to be over minutes, right? So I'm going to extend my grid. And I need hours up here. So that's going to be 1 hour equals 60 minutes. Now is my grid done? Yes, it is. And I know that because my milliliters cancel out and my hours cancel out and I have drops per minute left. When I do the math, it comes out to 15,000 over 600, which comes out to 25 drops per minute. What if it came out to 25.8 drops per minute? So what, that's right, it would be 26, my final answer. Good. Okay, now let's do one without the time conversion. The physician orders 200 milliliters of D5 normal saline over 45 minutes. It's a gravity drip. And the tubing has a drop factor of 10 drops per milliliter. What rate will you set your tubing? So since it's gravity, it's going to be in drops per minute. It says to do 200 over 45 minutes. I have a bag of 200 in my hand, and there are no conversions. So I'm going to start with my drop factor. which is 10 drops per milliliter. And then I need milliliters up here. So that's gonna be my 200. Over 45 minutes. Is my grid done?
Yeah.
Yes, it is. Because my milliliters cross out. And I have drops per minute left, which is what I'm solving for. Comes out to 2,000 on top. Over 45 on the bottom. Which comes out to 44.4. So my final answer is 44. Good job. Yay! We survived the IV PowerPoint. Any questions? Okay.